Hello, guys.
Okay, Lorenzo, thanks, and let's see what's new now with latest Homer.
So what we'll do today, and thank you for being here, is a little bit of crossover between a workshop and a presentation. So I'm not going to actually do anything live, but I swear I did it last night. So it's going to be representing something that you guys can do, and it's also going to be heavily Docker-based. So I decided to just build up examples that you can just go and replicate really easy. And the purpose is to give you an idea how to configure the capture agents mostly today. So yeah, a little bit super brief introduction. Our company is QXIP BV. We're based in Amsterdam. We mostly take care of the Homer and Sipcapture development, but we also do a bunch of other things. And of course, we provide support for it to quite a good number of customers nowadays. Even if many don't pay, it's open source. But still, they use the product, and we give them a hand, getting up in shape. Not much to say here. We'll see everything and all the details. If you're interested, qxip.net is our website. So today we'll see a little bit of the detail, or it's an anticipation of the Sipcapture stack. We'll call it that way. So what's really going on in Sipcapture, and what are the pieces of our solution before we go any further? So as you guys already know, we have capture servers. You can use, of course, Kamailio, OpenSips, or our own commercial engine for capturing the packets. So that's the centralized part of the solution where everything is sent and collected. Then we have a bunch of capture agents, and mostly we use built-in capture agents within the platforms that we all use and like. Here we have a quick breakdown. And then we have a bunch of code snippets and app integrations that are more or less ready to go and pick to implement app in your own application, should you want to do, or should you have a usage for it. And this is more or less, the environment that we're using nowadays to make it all work. Just a raise of hands to see how quickly I can skip the next slides. How many of you already have an idea what Homer is and why you should be using it? Good, not bad. Thank you, guys. See you next year. So Homer is a little bit of a VoIP and RTC time machine, if you will. So it's a place where you can get all of your messages, as we have said. Mostly it's built around a capture server and capture agents. So capture agents, sorry, the quality is terrible. Well, but the software is good. Capture server, we already said it. It can be either Kamailio or OpenSips in the open source range. It collects all the packets and so on. Capture agents are really the important part. Those are the pieces of the infrastructure that do send the messages and the content that you want to see and search in Homer. Here's the breakdown. The two platforms that we can use today will, of course, be looking mostly at the Kamailio part. So what's inside a capture server? So a capture server is really a Kamailio instance running the Sipcapture module mostly, and a bunch of other modules that we do use to make it all work and do the magic. Mostly, the important parts when you start a new node is just the initial configuration. This is all within the Kamailio config. You just define basically here your connectivity to the database part and some of the options that you have as you build the Homer capture server. This is the typical modules that we end up loading. In the little box, you see the optional ones in case you also do a geo correlation or you send custom statistics to the cluster. So this is non-SIP stuff. For the rest, it's all based around Alexander's carefully built Kamailio config, which really just handles all of the inbound traffic, and it creates custom statistics based on what we receive. So you not only get to receive and get all of those packets in the database for later searching, but you can also create a whole bunch of statistics and really whatever you want with it. It's in Kamailio programming, so you can just go in there, change it, make it work for your business, for your purposes. So how do we install Homer? Up until last time you saw us, it was quite a mess. Everything was new. It was kind of tedious to get it up and running. today it's as easy as one line. So we're back to the good old bash installer. What it does is expects you to run it, of course, on a vanilla Debian 8 or CentOS 7 image. It just downloads all of the components and configures the interaction between them to get a capture node up and running in basically just a few minutes. We say 5. People that use it clock it at 3, but it doesn't change it much. What it installs is represented down there, so you just get basically one server with the Apache, PHP, which are running the API and the user interface, Kamailio, and of course MySQL. But as anticipated, we built almost the entire workshop examples on Docker. So of course, there is a Docker image for Homer. Actually, there's more. We have a self-contained image, which is mostly purpose for testing and giving Homer a quick bite without too much mess. And then we have a multi-container set as well, which has been created by Doug Smith. And it basically breaks down Homer into its separate pieces in separate components so that you can scale it however you want. But if you're just giving it a try, the Homer Docker container on our repository does exactly that. So yeah, once you get it up and running, you just do your first login. Sorry again about this terrible quality. I just exported it now. Sucks. Default login, you get into Homer, and as you probably, many of you already know, you can build your own dashboards, you can build your own search farms, you can search and find your calls, see the call flows, see syslogs, see quality statistics and all that, and it looks really cool, except that when you install it, there's no data in it. So that's where most people actually find their first small challenge, getting data into Homer. And this is what this workshop is going to be about. So we'll see how, what the major players are and how to get them up and running. So feeding Homer. And it's not just about signaling anymore. So the up until recently, Homer was really purposed just for SIP signaling. But in the recent months, in this last year, we extended it a whole lot. So now it can basically accept any protocol as long as the coding part is there. But the framework is ready to accept it, and we already have some examples that we'll see today. So first and easier case, of course, capture agent can be Kamailio itself. So we have the Siptrace module, which many of you will already be well familiar with. Here's a quick breakdown of how it typically is configured. So this is just, imagine it's a normally running Kamailio instance, and all you have to do is really load the Siptrace module, configure it, as you see there, to tell it where you want to send the traffic and how, and that's it. Then you just call the Siptrace, you set the flag, in your route and reply route, and that's it. That's all you need to cover the most simple scenario, which is capturing just about everything you handle. And very similarly, in OpenSIPs, you can do, of course, pretty much the same thing. The Sipcapture module is quite slightly different there, so you can do a little more different filtering, but it's really the same stuff. Now, a really good beast is FreeSwitch. So let's see a little bit about FreeSwitch. So FreeSwitch has actually been the first platform to have a built-in capture agent. So it's the it's very much where the idea of the integrated capture agent started. And recently, we finally took the time with the team to update it to the latest HEP version. So now FreeSwitch, starting from version 1.6.8, supports HEP 2 and 3. As well as other nifty things. So the main difference is that you configure it. So in the capture server details, you can now specify which version of HEP you want to use. And of course, it has to be supported by the collector and the capture ID, which is useful to differentiate between instances that are sending traffic. So as we said, we decided to use a container just to show how easy and quick it would be to get a new instance configured to duplicate traffic and not just traffic. So once you get it up and running, and I'm not going to spend a lot of time here, many of you are already familiar, but this PDF can work as an example for those who are not. We can just spin up FreeSwitch 1.6.8 container, which we actually built for the purpose. And it already comes with most of the modules and the applications that we need. So what we really have to do is just go in our autoload Sophia config and just configure the first part, which is the capture server address. And you can see an example right here in the middle. All you have to do is define the protocol, the IP, and the port where you want to receive the traffic. followed, if you want, optionally by the HEP version. By default is going to be 3, and the capture ID by default is going to be 100. Once you did this, you can decide inside of your profiles whether you want to duplicate the messages or not. And the logic is very similar. So inside the internal and external XML configs, you will find a Sipcapture parameter that you can set to yes if you want to capture, of course. And then, yeah, pretty much all you have to do is reload the config, and off you go. You can also control those directly from the CLI, so you can set, as you see, the Sophia global capture flag on and off, and you can do the same also for the individual profile. So Sophia profile internal capture on does basically the same as setting the option there. It's all nice. The only thing that's going to be missing by default is correlation. So when you're going to fork a leg within FreeSwitch, by default, I guess the UID would be totally different, so you wouldn't have correlation between the legs in Homer. This is very easy to solve, and it's supported natively in Homer. What we do is we just add an X CID on the second leg, carrying the original call ID. And this doesn't really have to be sent out to the customer. This is something that can only just exist, you know, within your network. You can drop it again at your edge, at the SBC. You can just get rid of it. And it's enough for Homer to be able to correlate those two sessions. So once we see session A with a call ID, session B, completely different call ID from 2, but it has an XCID, we can just leverage it to get those legs together. And what you'll get at the end is just the typical outcome. So you would see all of your messages. Here are filtered by invite just for simplicity. You can see your call flow. You can inspect the messages, and so on. But there's more. So we said it's not just about signaling. So what we did recently is we extended our HEPIPE tool to talk to ESL. Right now we're extending it once again to talk to MQ, but what it does is exactly the same. So what we do is we harvest basically the event socket, and we look for events with the correlation factor that we can just send to Homer and use in our investigation. In this case, we're looking for media reports, but we're actually also taking all of the session handling within FreeSwitch. You can just take whatever you want from the event socket that has to do with your session, decide in AppPipe if you want to forward it, if you want to handle it, and whatnot, and just send it off to Homer. So what it looks like, something like this. So in the you would have your call flow, you would have your reports, and then you would have a logs tab where you basically would see what FreeSwitch was doing internally when it was handling the session. So this gives you another dimension into troubleshooting. You just, signaling is not always enough. Here you can see also what the system was doing. And you can extend it to just about anything you want. So we also do it with media reports. We're able to get RTCP packets relayed by FreeSwitch and send it to Homer. We can take the final report of FreeSwitch and use it, and so on and so forth. So it's pretty cool stuff, and a lot more about this you will find in the next version of the FreeSwitch book, which we're trying to contribute some material to. It's going to be very interesting. Similarly, Asterisk has the same, or well, similar features. What we did there is implement a few modules. Actually, Alexander did with the Asterisk team. So we have REST-HEP, PJSIP, and REST-HEP RTCP. Once you load them into the system, what they do is pretty self-intuitive. So they will basically allow you to duplicate all of the traffic from your Asterisk instance, as well as the RTCP packets that you generate or relay to a Homer server for later inspection and troubleshooting, and so on and so forth. What we did here is very much of the same. So we built a brand new Docker image with Asterisk 13.1 with PJSIP and the HEP modules enabled by default. So you can just pull it, run it, and as you can see in the modules, those are the three guys that you want to have up and running when you want to use it with Homer. How you configure them? You just open up the dedicated file, and mind, this file will be there even if you didn't build the module, so don't be confused just by the fact that it's there. You actually need to compile it with the app modules and PJSIP channel. Once you have it, it's just about really one parameter, which is the capture address. You can also do set a password and an ID, but those are optional. The capture address exactly will just tell Asterisk where to send those packets. And mind, if you load the REST-HEP RTCP module, the second part will happen by itself. So you don't have to configure anything else to have the RTCP packets forwarded as well when they exist. Correlation is internal, so nothing to do there. Whatever you have in the system, you will see in Homer as well. Once again, here's a quick example. The session here is forked, but the system is able to pull those legs together. You can see all of the details. And of course, same thing as before, you would see also the QoS tab with the quality reports. Now, we have another interesting example where we have looked for one of our users into logging the WebSocket transactions of Kamailio inside of Homer. So you want to see what happens, where the sessions come from, what the system is doing, and so on and so forth. So we just thought this was a really good example to explain a very general approach to this kind of problem that you can undertake with Homer. So as we mentioned before, we have a small Node.js tool which is called HepPipe. What it does exactly, it pipes data into HEP format towards Homer. So what we did, just to display how flexible and dynamic it can be for mostly for proof of concept, but not necessarily. I mean, we have people that actually use this on their live systems. What we did here is we configured a custom log stream from Kamailio handling WebSocket session, where we log a bunch of details about that session. As you can see, method, request, and a bunch of details about the security, the protocol, and so on and so forth. Into a custom log, so which we have handled via rsys_log. So everything is very simple, very brutal, just for the purpose of showing how it works in the most simple way possible. So this log is generated every time a session, of course, is created. And on the other side of the line is HepPipe, which is going to be basically looking at the streaming log, capturing lines, and checking them against a regex filter. The purpose of the filter is to extract the call ID. So if we want to send data to Homer, of course we can, but unless it has a correlation ID, it's pretty much going to be totally useless. So if you cannot correlate data to the session that it belongs to, I mean, that's not going to be very useful for anything at all. So here, once again, the script will look at the Homer WSS.log, and within it has, of course, the HEP server parameter, which are used to send it. But more importantly, in the logs array, we do see how to define groups that we want to scan. So we can define a specific path for a log, a pattern with the regex rule that we want to use, and a tag and a host that we can just include for sending them. Once you do it, everything you send, this is a little bit of a breakdown of how the schematics of it. So you have a call coming in, we use RTP engine and Kamailio to handle it, and those two elements are already able on their own to send statistics back to Homer. We'll see how with RTP engine just next. And on top, you see how we can feed this custom log, take this information, feed it to a pipe, have it come to Homer, and this is a little bit how it looks when you're done. So you would see basically the session. We use JS-SIP for this example, so it was actual SIP inside. But what we were interested in is exactly the WebSocket details. And here, exactly in the session, you would see pretty much what happened as you were handling. And if everything works, you don't care. When it breaks, you do. So there you find it. And just as a snapshot of another evolution of this that we're working on, we can actually handle the WebRTC session per se. So it's not SIP, it's something else. In this case, it's a JSON. It's a JSON object really that gets exchanged. But as you can see, we have extended Homer to handle this custom protocol, and you can see it displayed in the call flow. You can see it in a custom pop-up format, and so on and so forth. So this is possible now with any protocol. So it could be DNS, it could be Diameter, you name it. So next case that will come up will allow us to add one more and more. So if you have ideas or requirements, ping us and we'll make it work. The example here that you see is with the RTC engine from Sipwise. And if you're curious, we can also demo it outside so you can see how it actually works and click around it. Another example that we have, it kind of fits into the HepPipe area, is we can also use the same mechanism to log remote devices. So let's say that we have a device somewhere else that it's interacting with our network. In this case, we have, again, an example with JSZip, which was just perfect for the purpose. What we did in this case is we basically forked, or we override the logging functionality of the client. We route it to a HEP module, and we send it to Homer. So now all of a sudden you can also see what the client was doing with a little bit of patchwork. This is just an example, but we can share how we actually did it with a couple of cases. And yeah, this is something that ideally you want to switch on specific cases, but nevertheless, it's very useful to tell what was happening on the remote side of the session if you have no idea. Now, if all of the above fails, or you cannot do it, or you have an older version of FreeSwitch, Asterisk, or you just don't want to touch your production system to do monitoring, it's got to be passive, there's Kept Agent for that. So Kept Agent is our universal capture agent framework, because it really is a framework where you can extend the concept that Alexander created. In maybe if there's time at the end, he can get up and give us a little bit of extension, or you can check his presentation on Friday where we go into more detail about what's coming in the project. So as we said, Kept Agent is a universal HEP or EEP capture agent. It's modular, so it has different ways to capture packets, handle packets, and send them out. By default, it's going to use a PCAP socket, it's going to use a Sipcapture plan, and it's going to use HEP to send them back to Homer. But this can be extended. We also have a JSON module, so you can literally just use it to for different purposes unrelated to Homer. Same thing as before, we have created a Docker container with the latest version, which is 6.1. Yeah, we're just running it. If you are, about a serious or a real system, it's very easy to compile it. And this is actually what's happening inside of the Docker container. What we open here is nothing at all. So this is going to work using the host network, so that you can capture everything that all of your containers are doing. If you're using Docker, in the other case, it doesn't matter. How does it work? Well, a few people are confused with the new cascading configuration of Kept Agent 6. What we did there is we tried to emulate a feature that we like in other projects, which is basically the ability to create single pieces of configuration that you can include and cascade within other pieces of configuration. So we broke down basically the modules configuration to different parts. The main one is, as always, Kept Agent XML. Kept Agent XML defines where on the system your libraries, your binaries, your configuration files, and so on are located, and it's quite key to orchestrating its execution. Other than that, I mean, it's just about a few details, and we'll see a quick example here how to get a default Kept Agent up and running. So the first thing you want to do is define the socket. So how we're going to capture the packets, where are we going to capture them from, and what plan is going to process them. This is done in the socket pcap XML by default. This module is enabled if you compile Kept Agent without any options. And not much to define here. Is this the interface? So in this example, we'll capture from any. The port range that you want to use for the specific protocol, it's SIP, so we'll go 5060, 5091 in the example that we've seen. And Sipcapture plan config is the file where we'll tell Kept Agent what to do with those packets before sending them out, before processing them. So first step, really easy. Capture plan is a separate file. There's a directory called capture plans inside the default Kept Agent install location. So you can see there's already a few for SIP, RTCP, and RTCP XR. What's happening inside this file? Basically, it's a pipeline where we tell Kept Agent what to do. So the first check, as you can see, is on the message size. So is the message large enough to be processed, to be meaningful? If it is, you go in. And you see we have a source IP check. So is this packet coming from a specific source that I don't care about? If so, just drop it. Don't process it. Don't duplicate it. So this is very important because it gives you an additional point where you can decide how the packet mirroring is going to work. Sometimes, before you are forced to mirror too much into Homer and then rotate it, drop it, or just do nothing with it. Right now, you can already do it in a capture agent plan. So you can decide what's interesting, what's not. Once you get to a packet that you care about, you pipe it to basically an outbound socket, a transport socket, which is defined in the next step. In this case, it will be in transport HEP, and the name of the socket is HEP socket. If everything works, the packet is gone. If it doesn't, you get an error message. That's what you will see when the capture server is down. So many people tend to misunderstand this error. If you start a capt agent and there's nothing listening, you will get a error sending HEP message. If everything fails, we just drop it and it goes off out of the memory. The transport socket, which is the last part of the puzzle here, defines how we're going to encapsulate this packet and how we're going to ship it somewhere. So in this case, quite intuitive. Transport HEP uses the HEP encapsulation protocol. And all you have to do here, similarly to the other platform, maybe a little more verbose and detail, you define the version of the protocol that you're going to use, the capture host when you're going to be sending it, the port, the protocol, UDP or TCP, capture ID, password, and compression, which is, I think, right now only supported in capt agent. But it's a feature on the backend, so you can also compress the payload. And that's really much all you have to do. Next, you can just go ahead, run the capt agent, giving it the full path to your configuration if you need to. You can have multiple capt agents running at the same time. -n just runs it in the foreground. And that's it. So in just 3 steps, you can get your flexible agent configured. But that's not it, because as we said, capt agent is modular and it's easy to extend. And the first extension was exactly to cover the RTCP mirroring, which is something that's very useful and a cheap way to recycle your existing packets and get QoS media statistics out of them in Homer. What you do is very similar. So as we said before, in the socket PCAP, you can have multiple profiles, multiple pipelines feeding multiple capture plans. So we just basically go in, enable an additional profile. This is in by default, it's just disabled. So what you would do is just on the first line, change it to true to have it enabled. And then inside, similarly to the other profile that we have seen, you decide the device where you're going to be capturing and the mode. So if you want to reassemble the packets, if you're going to use a kernel ring buffer, and so on and so forth. So we try to keep it as flexible as possible and dynamic, and it's easy to extend. So this is all on GitHub. You can go see it and take it wherever you want. In this case, we define a port range, which is for the should correspond to the range that you use for RTP and consequently RTCP packets. What about doing it directly inside a relay? This is now possible. So RTP engine from Sipwise, which is basically a drop-in replacement for RTP proxy with advanced functionality and performance as well, is now able and featured to also do the same job that we have just seen in capt agent. So normally RTP engine is going to be handling all of your RTP and RTCP packets by default. So why not just recycle them directly inside the engine? Why should we capture them again if we don't have to? And indeed, we don't have to. So with just 3 parameters, this is currently only available if you compile it yourself, but I hear from in a few weeks' time, this will be available in the standard package of RTP engine from Sipwise. Off you go. You just define 3 additional parameters. Here we see a full example, but it's not going to tell you much more than you already know, and it's compatible with what you have seen in the previous presentation. So just 3 flags, and everything that RTP agent is doing will be visible in Homer as well. How does it look? It looks something like this. So you get basically for each stream, you get out packets, jitter, packet loss, whatever else it's available will be automatically displayed. We do calculate pseudo MOS inside of the platform if it's not provided directly already by the agent. You can see a breakdown of the RTP transactions and so on and so forth. And of course, what you get in return is full visibility over what those sessions were actually doing, how the client was seeing it, and so on and so forth. Mind this tab in Homer supports multiple type of reports. So we have RTCP, which are just captured off the network. We have XRTP or PRTP stats, which are coming directly from the user agent in the buy or 200K final message. Or we can have custom analysis coming from RTP agent. RTP agent is basically a commercial extension of capt agent, and it does what everybody wants. So it provides a privacy-friendly reporting and analytics tool for real, actual RTP. So we look at the streams, we process each and every RTP packet that we see. We don't store anything to disk, unlike some other solutions that you might be thinking of right now. Nothing goes to disk. So this is why we're privacy friendly. We don't even decode it unless you want it to. It doesn't go anywhere. We just determine all of the details. So we know the SDP already of the session, so we can extrapolate from that the codec and everything else. And based on that information, we do tailored analysis of the stream. The purpose is to deliver all of the parameters that you would see in Wireshark looking at an RTP stream without actually having the RTP stream, without storing the RTP stream, so without any storage challenges and so on and so forth. And we also add the cherry on top, which is the MOS scoring. The way this works is basically it generates a report each X seconds you decide. So let's say each 30 seconds you want to have a full report on every stream that's running on your network. This is what the tool does. Once those streams are in Homer, you would basically see them exactly as before. So for each time location, you would have all of these details, the MOS and everything else. And of course, the ability to know exactly what those sessions were doing. So RTCP gives us only a shadow of the quality as seen by the user agent, but this is actually us analyzing and sniffing the network. So if nothing else works, this is a way to do it. And we also have extensions for proper lawful interception functionality, so you can actually intercept sessions, dump them to disk, including everything, but this goes a little bit outside of the scope. We have seen all of the complex approaches, but let's see now also the simple ones. This is something you might remember from the last workshop, but it's very important, and we think it can save your life one of these days. So both SIPgrep and SNgrep, which tend to be quite common across systems featured for voice handling, both support Homer encapsulation protocol. So you're not just tied to the console. You don't have to copy paste or remember what you did. You can just fork everything to Homer, and mind, this does not impact your ongoing session. So you can continue doing your troubleshooting and just duplicate everything to a capture server if you can reach it, of course. For later analysis, sharing it back with the customer, whatever the scope would be. We spoke about HEPIPE. So just to zoom in a little more, HEPIPE can be used, as we have seen, for ESL interaction. We can look at custom logs. But we can look, of course, also at application logs. So we took an example here from the Sipwise Kamailio integration in their NGCP platform. So their platform basically is very verbose, and it logs a lot of useful and sometimes critical information about all of the elements that they use, specifically Kamailio. Yeah, I mean, you end up having those information in the log. Normally, what you would do is just, start from your SIP session, maybe take the call ID or relevant details, and then go and tail those logs manually, looking for the call that you're looking for. HEPIPE basically strips this out, so it allows you to look at those logs on your behalf. As we have seen before, in a similar fashion, extract the call ID, which is contained in a string locally. If it's not, you can change the log to contain it and do the same job yourself, and stream it back to Homer. The configuration is super, super, super dumb. We have seen it before, but just to make sure you get it, you just download, you clone HEPIPE. It's a Node application, so npm install does it all for you, nothing else required there. And what it will do is it will actually download the hep.js node module, which is just used to create the packet outbound and send it via UDP or TCP. And that's it. Once you're done, you would basically end up with something like this. So all of those logs that you were manually tailing on the systems that were handling the call are now directly available in Homer. Tag, they're searchable, you can filter them, and hopefully it can make everybody else's life easy when you're dealing with a similar scenario. We use the NGCP just because it's something that we have in our daily life, but again, it's easy to replicate with any system, and it doesn't have to be a Kamailio log, it could be something else's log. As long as you can fit in a correlation ID, you're good to go. I also included a quick example of how we use BearSIP with Homer. Probably many of you already know BearSIP is a really, really cool and flexible command line SIP user agent. What we did over the last year, well, actually it's more than a year. In the last year we did RTCP XR, but I don't think it's fully published, but it's there. Anyway, Bearsip is able to be enabled to send RTP statistics and RTCP XR published messages to your infrastructure. Similar as before, blah, blah, blah. We have a Docker image, which we have built on purpose. It opens only 5060 and 8080. Those are used just for the traffic and for the API, so you can control everything about Bearsip also from its HTTP API. You go in your configuration, you just gotta set yes, say yes to RTP stats and RTCP XR stats. You set an RTCP XR collector if you have one. To do this, you would have to pull our branch version, but it's gonna be published soon. Add a SIP account and make a call. And what this would produce is similar to what we have seen before, but this information is coming from Bearsip. So we didn't sniff anything off the network related to the quality of this call. It's the agent that told us directly. So we have received the statistics directly either, well, it's actually two types. So the XRTP stats were received at the end of the call, and those are also RTCP statistics that we have seen otherwise in the stream. And coming from the agent, this is hopefully going to be a very good representation of how the customer quality was. So if it sucks here, it probably did really suck for the customer. And talking about customer, sometimes when you have data in Homer, you have to share it with them. And you need to show them that they're wrong. That's always the case, right? It's always the customer's fault, but you got to be nice and tell them in a way that's convincing. And there are two approaches in Homer. One, if you can afford giving public access to part of your Homer instance, there's a built-in share link functionality. What it does, it basically takes whatever session or group of sessions that you're looking at, it creates a unique snapshot with a unique ID, so something that you cannot relate back to your internal data, you cannot search, modify, or anything else. And it just gives you a unique URL that you can share with any party for letting them see, but still you would have to give them access to Homer, which is not always a good idea or feasible even. So we also added the Share Cloud functionality. It's called Share Cloud, but it's actually Cloud Shark. You can adapt it to anything else, but by default it supports our good friends Cloud Shark. It's very simple. What we do, we create a PCAP of the session, we upload it to your cloud tool, whatever it be. And there you have it. Oh, sorry, there's an example right there. In this case, this would be on their infrastructure, and you don't have to worry. It's just a PCAP that you send somebody. The nice thing is that you can add nodes and maybe re-import it back, but this is maybe for another workshop. To configure it, it's just a couple of parameters in the API preferences of Homer. So you just enable cloud storage. You provide your API key. This could be a public one as well, I think, and the storage URI. As you see, those three parameters pretty clearly suggest that you can replace it with your own integration of the same. So if you come up with something better, let us know. We'll change the name or we'll extend it to support it or publicize it. Last mention about the API. So many of you already know, but starting from Homer 5, everything that we do is based on our REST API. So there's no tricks, no direct access, no special functions. Everything is directly off the API. You can, of course, inspect what Homer is doing as you're using it to see how we interact, what calls we make, what data we return. It would take probably days to go through those details, but it's pretty easy to determine. What we did to create a good example of how to use the API for something useful, potentially, it's the Snmp Gateway. So we, on our repository, there's an Snmp Gateway to the Homer API that you can just use to basically pull information using Snmp. And it displays a few methods to just interface with the API, create a token, authenticate, get information, refresh the session, and that kind of stuff. Which would be useful exactly for integrating with third-party tools. Maybe you have a customer portal, you want to get some information of Homer into whatever it be. You will find in that example a good way to approach it. For everything else, there's our wiki. So we try to spend a lot of time keeping our GitHub wiki, and this is going to be in the primary Homer repository. So we have a bunch of sub-projects, but all of the information is on the Homer wiki itself. And there you will find recaps for all of the examples that we have seen today, probably with additional data. A lot of details how to configure the user interface for correlation, aliasing, so on and so forth, how to create panels, widgets, new data sources, users, management, and also some more capture agent options that we couldn't fit in the presentation today. And so much more. So help yourself to the information. It's all there. And if you don't find it, send us an email. We'll add it. It happens. Sometimes you do a lot of things and you forget to document it. And that's pretty much it. So ask us almost anything. It's going to be about MySQL. I already know. Alexander, come up. Thanks, guys. I don't know if there's going to be actual questions, so that was just a joke, but let's go on with the MySQL.
It works.
Oh, you'll need this.
No,
it's all very good, very impressive. And you see it all in action, and it is indeed extremely impressive. I would like to know, we've had discussions and talks already from Carsten about IMS and how SIP signaling and diameter signaling is all passed around IMS. Where are you going with that? Are you going to give us a tool that will capture it all and allow us to correlate it all together?
Where's William?
Right here. Okay. It's a question to him.
The answer is just him raising his hand. It should tell you where this is going.
If it's with William, I'm going to take that as a yes, it will happen.
We're talking about it actively, and again, as for many other things in our project, we're live. So, I mean, if somebody comes to us with a challenge, that's probably the next feature that we're going to be working on. We tend not to, push our ways down. We just wait for people to have a need that we can help satisfy. And this seems to be next.
Yeah, normally doing by on demand.
Yeah. We listen to what people need and we try to make it happen.
You were talking about you have an integration into RTP engine to do the RTP stream duplication.
Sipwise did, yeah.
If I'm not mistaken, it tries to by default do the media relay in kernel space. So if you're using the kernel module, would you still then be sending the Homer recapitulation from the kernel module?
I wish we had Richard here to tell you. No, this is not going to be sent by the kernel module. I think that's just where the statistics are generated. The sending module is not, I think, running.
No, it's sent by user agent, and it's just duplicated what user agent sent. Yeah. So it's just a hook, and which will be duplicated to us.
Okay, question there. Okay, I'll take this short and then I come there.
Does Homer 5 support selecting more than one call leg? Like I think in Homer 3 you can only do 2 call legs at a time. But does it have 4 or 5 call legs for the same call? Show that in one graph?
Yes, we do. The call flow part from Homer 3 was completely redesigned. So that's changed incredibly. I think it supports up to, we don't have a limit in terms of how many sessions.
We have only limit on query, which you can extend. Yeah? So how many messages you will receive at once. Yeah? So we can extend up to 1,000 messages, and it will be displayed on canvas. It's because it's canvas, it's not SVG, and therefore it's no stops to display all messages what you have.
But before it was really a limitation in the way we were pulling the data in Homer 3.
Only MySQL, yeah.
It's MySQL limitation. There you have it.
So in your demos, you're using MySQL. Can you expand on your database support? Because I believe in another conversation we had said you'd, Postgres.
That's you. I'll give you the microphone too.
Okay.
Because this is going to be interesting. Oh, there you go.
So, can you repeat your question again?
Postgres support, another database?
Yeah, okay. We discussed already during ClueCon. We plan to integrate with Postgres support deeply. Yeah? So we have created SQL layer which can support any type of SQL inside. So Kamailio or another engine can insert everything in Postgres without any limitation. It's only displayed. Yeah. So and we are working on it. And I hope, during next month we will work hard on it. And I think in next month you will see first version which can, let's say, not 100% supported, but almost 90%, let's say. So we promise we will do it. Yeah. Matthew?
Yeah, so this is kind of there's a little bit of a wind up to the question. Well, in sort of the web world / application stack world, the ELK stack has sort of become the de facto standard for doing distributed logging. And there's a whole lot of stuff in there to do really fine-grained querying and things on your logs. Given the fact that you're starting to suck in sort of application logs from FreeSwitch and potentially from other sources, philosophically, where are you envisioning the Homer project having that dividing line between logs coming from your monolithic VoIP applications versus the sort of Node.js applications that are built on top of that?
Well, the logic is really, really simple. We want you to recycle your data. So the direction will be to make Homer able to work with it, which is already possible today. So we do have a hook to Elasticsearch. We do have a look to InfluxDB as well. If your data is already there, we want you to recycle it. So everything that you see is purpose for people that don't have anything in place and need it. If you already have it in place, then you should only have the signaling in Homer, and you should have your logs where you already have your logs, and just make a connector to fetch them out, which is technically already possible. We're just exactly waiting for a good excuse to put it together, but it's already there. So our logic is do not duplicate, even if we're a mirroring tool. But yeah, if the information exists anywhere, we just want to reach it and recycle it.
Just two comments. Also, exactly with Elasticsearch or InfluxDB, if you have some data in InfluxDB or Elasticsearch in Homer 5, you can display it natively with our charts stuff. And you can also make a query. It will be present after tomorrow. You can make query to Elasticsearch and display this information exactly in this tab. So we will show it.
Friday.
Friday.
Presentation.
Are you able to capture SIP traffic from within an Ipsec connection?
Depends how it's encrypted.
Yeah, exactly.
How IPsec?
Yeah.
How secure?
So if the key exchange is sorry, I can't hear you.
Okay, so you are not a capability of, let's say, capturing the key exchange that may happen on the same machine to decode. No.
It's impossible. If it's one time key generator, it's impossible to decrypt. So no key, no hands, no cookies. Yeah, but no key, no data.
But there's an important part here. We can still. We can still do the statistics part, especially with the kept agent module. This does not impact the ability of the agent to draw the statistics, because we don't look into the payload, so we don't actually need to decode it to do that part.
But it's only, for example, in WebRTC, you have SRTP, and exactly we can make statistics based on your SRTP stream. You don't need to check payload. In this case, you will see exactly jitter and so on. We can calculate it on demand.
For signaling, oh God, that was loud. SNgrep, I don't know, does it work? No, it doesn't.
Ah, okay.
Ash.
It's better.
Have one each monitor.
Sorry. I should know. SNgrep supports HEP, and it supports partially decrypting TLS as well. So if that works, yeah, the answer is yes. If that doesn't work, the answer is currently impossible.
Yeah, so the thing is here with forward privacy algorithms. So if that algorithm is used, you can really sniff. If it's one of the older algorithms, then you can see the key exchange, and SNgrep can
decode it. If you have private key, exactly, we can decode it. If you don't have private key, sorry.
I assume the question was completely passively. So,
yeah, so if you use the null cipher, would you be able to see everything? I mean, inside your application?
In Kamailio.
Yes. Yes. Even if, I mean, our approach to the problem is similar as before. I mean, if you can capture your data, you obviously own the infrastructure. If there's any point where you can capture, the clear part of that data, why make it complex? If it's impossible, of course, it's a new set of challenges. But more likely than not.
Yeah, if you have the keys, obviously it's possible because you
yes,
know
it's possible, but not necessarily.
Wireshark
You don't
and
want to
use
break your
traffic.
own network unless you have to, right? I mean, this opens up also some security concerns, which you have to consider before doing it. Is this the only way to do it? If the answer is yes, then of course that's the way to go. But if there's any other alternative that doesn't have to, put your privacy in danger or your encryption in danger. I mean, that key has to be shared to do it.
It's not about something special about security, but about using Homer for debugging IPsec, for example.
Absolutely, absolutely.
But again, Lorenzo said correctly, if you can capture somewhere where you already have decoded data, it's better to do in this place. But if you're talking about the WebSocket and client which sent only TLS data which could not be decoded, if you have private key, let's go.
Call the guys over ocean. Okay, for encrypted data. Okay, so thank you.
Thanks,
Lorenzo.
everyone.
Yeah, thank you.
Alexander.